Hey everyone, I want to talk, or well, really to compare spermatogenesis and oogenesis. All right, so if you remember, we talked already about, we compared mitosis with meiosis. Now, spermatogenesis is very similar to just straight meiosis. The difference is, though, that we are going to have, we start with the spermatogonia. It's going to undergo mitosis initially. And one of those cells is going to go back and replenish I think of it as replenishing the stock. So you never run out of those spermatogonia. The other cell is going to differentiate into a primary spermatocyte. That is then going to undergo meiosis, the first stage of meiosis 1. And remember, after meiosis 1, are we diploid or haploid? We're haploid. So these secondary spermatocytes are haploid. They undergo meiosis 2, and we get spermatids. Now notice, right, these are not sperm yet. They need to undergo spermiogenesis. We need an acrosome. We need the midpiece with the mitochondria. We need the flagellum. Then you get a sperm. All right. In oogenesis, if you remember, we have the oogonium before birth. At puberty, we're going to have a primary oocyte. It's going to undergo meiosis 1, and it'll be a secondary oocyte. If fertilization occurs, it will complete meiosis 2, and we'll have a fertilized ovum. Quite different from spermatogenesis, right? So when is it taking place? Oh, spermatogenesis, I forgot to mention, starts at puberty. Here, it started before birth. They were arrested in prophase 1, and then it resumes at puberty. All right, and we complete it. And how many cells do you get in spermatogenesis? You get 4. How many do you get here? 1. Why? Why do we only get 1? Well, we have a polar body and a polar body. We have 2 polar bodies. Now, wait a second. 1 plus 2 is 3. Where's that other? Well, it would be right there, right? But this polar body is going to disintegrate. It is not going to go on to do any more meiosis. Now, that's something else. Look how we started with mitosis to replenish that spermatogonium. Here, we're going straight into meiosis. In fact, we started meiosis even before birth. And also, I really like this. Supporting cells. They don't just do it all on their own, right? Here we have the sustentacular cells that are going to sustain the developing sperm. And we also even have, remember, outside of the blood-testes barrier, we have the interstitial cells. And those are going to be secreting the testosterone. Sustentacular cells are going to secrete that androgen-binding protein. All right, and for the developing ovum, we have the thecal cells and the granulosa cells wrapped right around it. And they're going to be making androgens and then converting those androgens into estrogens. So, and also giving nutrients to the egg as it develops. All right, a lot of differences, and it's really fascinating. And look how it's a form and function, right? The structure meets the purpose. We have the sperm cell. It sheds a lot of its cytoplasm. It has it keeps the mitochondria. It has the flagellum. And here, you just have this huge egg cell that has the granulosum cells that have been pouring nutrients into it, getting it ready. All right, so spermatogenesis versus oogenesis. Thanks, everyone.